session, virtual sky observing session. I'm Peggy Hernandez, the U46 Planetarium teacher. And the theme this week is odds and ends, but we will definitely every week spend some time looking at the night sky. And I'm going to ask you to go outside and do some observing at home as well. And in order to do that, I want you to be safe. So make sure that you know your territory. Check your path out to your observing site during the day so you can see if there's any rocks or holes that you might trip and fall in. Be careful. Go out with an adult or a family member if you need to. You will not need a flashlight, a cell phone, or a telescope to do anything that I show you. As a matter of fact, you should not use a flashlight. It'll ruin your night vision unless, of course, you have red cellophane or some kind of a red fabric covering the light to make it red. And in that case, it's okay for your night vision. You can use that, especially if you're going to use a star chart of any kind. You might want that red light so you can see the star chart. And the theme is odds and ends. And what I'm going to do is address some of the questions that I've been getting kind of repeatedly on the program. And just repeatedly in general, I've been having a lot of conversations about the Starlink program. I just want to tell you what it is. It's a SpaceX program, a SpaceX initiative. And Elon Musk's goal is to have internet everywhere. He's going to be the guy that has internet everywhere on the Earth. He's going to launch 12,000 small satellites in low Earth orbit, 12,000. And this picture really shows like a really good diagram of what it might look like. Kind of, these are each satellites. They talk to each other, they talk to ground receivers, and they will allow for internet access on the top of mountains, in the middle of the ocean on a ship, in the middle of the desert, absolutely everywhere, on airplanes. So it's like a humongous internet project, and it's going to take 12,000 satellites. Now he launches them about 60 at a time. Here's a picture from the International Space Station from the last launch, or one of the last launches. And each one of these little dashes is one of those Starlink satellites. He launches them 60 at a time in a string, and they move across the sky. They're looking towards the South Pole here. You're seeing the Aurora Borealis, or the Southern Lights, with the Starlink satellites going past. It might look more like this from your backyard. You happen to be in a good viewing spot where they're going to go right overhead. You know, the closer they are, the brighter they're going to look. The closer to sunset, the brighter they're going to look. That's probably Venus right there. It's a string of lights that parade across the sky. They move. If you're an astronomer and you're looking through your telescope on the night that some of them go by, well, some astronomers call this ruined, because as you're looking at this galaxy gajillions of miles away, these little satellite lights cross the path of the viewfinder. Those are all Starlink satellite lines in this image. And just to give you an idea, I said low Earth orbit. The Starlink's going to average about 350 miles above the Earth. The International Space Station's about 250 miles above the Earth. But your average satellite, the satellite big ones that are up there, are, you know, in the range of 600 miles up. So they're closer to us than regular satellites, but they're much smaller. And once they're at that orbit, over 300 miles above the Earth, you will not be able to see them. Once they've gone all the way up to their orbiting height, you will not be able to see them with your naked eye. And a lot of people think that satellites and rockets launch straight up off the Earth, like as if there was a launch pad here and you wanted to get a satellite here, that you just shoot it straight up, like in cartoons and stuff. And that is absolutely not true. They launch in the direction of the Earth spinning, and they go around the Earth multiple times, getting higher and higher until they get to their actual location. I don't know if Bob Kaplow's here on this Zoom. You can maybe add anything into that if you'd like. Raise your hand and let the moderator know. But that's the basic idea. That's why they're going to go by a location several times, and then they'll be up high enough that you won't be able to see them anymore. They're not doing anything to people. They're not sending out any kind of harmful signals or anything. They're launching satellites, 12,000 of them, to make this World Wide Web experience. Now on this page, I have some links. I want you to know that these are all available on the Planetarium Portal. To go to this portal, you go to the regular U46 website. Under departments, you can pick Observatory Planetarium, And then right here on the right, click here to go to the Planetarium Portal. It looks like this. On the front page, I always have this recording on that second bar. A short version is right above it. But look up here in the upper right, we got content resources and live events. If you click on content resources, all the links I just showed you are there for you to click on. And those links are pretty neat. One of them is this, an actual video of a SpaceLink launch. Oops, hold on. There we go.
Mrs. Hernandez, I wanted to let you know that Mr. Kaplow is unmuted.
Hey, Bob, you got anything to add for that?
Oh, thanks for inviting me to join you. I just took a look at what's visible from our area, either Elgin Planetarium and the surrounding area, and I don't see any good Starlink passes in the next week. But since you have people on this video that are elsewhere, they're going to have to check for themselves. And the site I use to check is one you've mentioned before. It's heavensabove.com.
Yes, and I have that on my program here too.
There are some passes that would be visible from here, but they're not bright enough to likely be able to be seen in our area with all of the light pollution that we have in the
I agree.
suburbs. Yeah,
So
it's
here is the Heavens Above site, the one that you just mentioned, for Starlink 6, one of the most recent ones. And we have exactly 0 viewings that we'll be able to see in the next few days. There's just not any, but I did just find this, that they've changed it now to May 17th. Yesterday it said May 18th for the next launch, which is Starlink 8. So next week when I do my program, I'll probably bring up if there's going to be any crossings from Starlink 8 that we might be able to see.
you won't see those in time, unfortunately, because they're launching after your date, and until the satellites are in orbit, they won't show up on the site.
Right. So next week when I'm on, I'm going to have it more updated, and maybe we might be able to look for, oh, they put them up after the launch.
Right. Heavens Above gets the data from NORAD once they're in orbit, and then they'll be able to tell us what we can see and when we can see it. But
Got it.
starting a couple days after that, I would check in to Heavens Above. And what I usually do, it's a little cumbersome to, if you go to that link you were just on for the Starlink passes, you have to check for each of the separate launches. I just take a look at what's visible tonight and set my threshold of brightness down to very bright. I think I use the 3.0 rather than the 4.0 or the 5.0.
Yeah.
And look at everything that's available and see if any Starlink stuff shows up. The good news is that about a week from now, the International Space Station will return to, again, at least for our area, into the visible status. And I've got, what do I have in front of me? The night of the 16th.
Here, I'm going to click on it.
Yep. So if you click
You
on the
guys all
ISS,
see the Heavens Above site?
right, if you click on the ISS link.
Right. There's a bunch of them. That's where we're going next. A bunch of International Space Station crossings. As a matter of fact, they're not all 3 and 4 and 2 in the morning. Starting about a week from today. Here's one on May 14th. That is at about 10 o'clock. There's an 11 o'clock, another 10 o'clock, and then there's even one on May 16th that goes all the way into the 8:37 hour, which it probably won't even be completely dark out. And their brightnesses are way brighter than a 3 or a 4. They're below 0, which means these are very, very bright crossings. So this Heavens Above site is an excellent place. Here's the home page. Excellent place for you to go if you want to watch for International Space Station crossings and Starlink crossings. They're right here, ISS and Starlink crossings. That's what you're going to want to click. You do have to register your location. Otherwise, they can't tell you what's going to cross because they don't know your location, but you do it for your specific location, and it's right there at the tip of your fingers. So that's
one more useful tip for this site. If you
Yes.
go to the change your observing location, tell it whether you are, whether it's Elgin, Illinois, or Houston, Texas, or Hawaii, or wherever, and then bookmark it with that link that has your location in it. Next time you go in, it'll know right where you're at, and you don't have to keep putting that in every time.
Yeah, I don't have to put it in every time, so it must have saved me somehow. And it wasn't even this complicated. It was easier. So yeah, It's a great website for sure. Thanks, Bob.
You're welcome. Glad to join you. Thanks for the invite.
All right, here we go then. So at the portal, you can find the links for those really neat websites. And that's what that looked like. We have no Starlink crossings. Looks like the next launch is the 17th. That's what I just showed you. Those are those bright ones that are in the evening time rather than the middle of the night. Hey, another question I keep getting is telescope and binocular questions. First of all, the best way to learn the sky is just with your eyes. Once you know a few constellations and you have an idea of how to find them, it gets interesting if you want to take a look at them with some kind of viewing device. And if you want to use binoculars, I mean, obviously you all know how to use them. You hold them up to your eyes, right? Well, there's some tricks to using them correctly, whether you're looking for birds or for stars in the sky. And here's the first 3 steps. Aim your body completely at the object you're trying to look at. Have the binoculars over your neck, the strap, so you won't accidentally drop them. Just always have the neck strap on. Look at the object that you want to look at, whether it's a bird down the street or the Orion Nebula or the moon or whatever. And then here's the most important step. While you're staring at the moon or whatever, slowly bring the binoculars up to your eyes without taking your eyes off of the target. Don't look down at the binoculars to check to see if they're still dangling from the strap on your neck. You can feel them, they're there. Just grab them without looking at them and bring them up to your eyes. And I'm going to try to show you what I mean, the correct way to bring these up. So I have binoculars, I have the neck strap on, and if I see something really cool over there, I'm going to say, wow, I see something really cool over there. I got to turn my body to face it. And then while I'm staring at the object, don't take your eyes off the object. Stare at the object and bring the binoculars up to your eyes. Hey, there it is. It'll be there. If you try to do it this way, oh, there's something cool over there. Hey, I don't see it. Hey, I can't find it. Oh, these things don't work. I can't find anything. You will never find a sky object by doing this. It doesn't work. You have to hold yourself still, aimed in the right direction, bring the binoculars up to your eyes, and it'll be there. It might even take some practice. You might have to do it a few times. Practice outside, looking for something, a fire hydrant down the street, a bird that you see on a tree that's a few houses away. Do some practice and you'll get better at it. And then you can do it at night and find, well, it's really neat to look at the moon through binoculars. Oh yeah, and by the way, never look at the sun with binoculars when you're outside practicing during the day. So a couple of things about our sky tour for tonight. I want you to notice that early in the evening, before it's even dark out, now this is 8:42. 8:42 is pretty late, but it's not completely dark then. Almost, but notice that Orion the Hunter, half of him is missing. Half of him is already below the horizon. Sirius is really low. Even Venus is way lower in the sky. You guys, this is the last week to see Venus really easily in the western sky. If we go much later, we would see that Orion is completely gone. By about 9:30, 10 o'clock, Betelgeuse is completely gone as well. Now, Orion the Hunter is often associated with Greek mythology. Oh, he was a fantastic character in Greek mythology. Tall, he goes blind at one point, and then he's like, his vision gets brought back. And he always looks like he's chasing or hunting Taurus the bull. You can kind of see the bull right here. And his belt points right to the eye of the bull, actually. And I've always thought, oh, there's some mythological tale with that. It turns out there's not. There is no ancient Greek mythological tale about Orion facing the hunter, like hunting Taurus the bull. Now, Orion the Hunter is often associated with the Pleiades in the shoulder of the bull. There is a story, the seven sisters are also known as the Pleiades and Orion, but mostly Orion is actually connected with Scorpius. And he's pitted against the Scorpion because he's a hunter and he loses. The Scorpion actually kills Orion And in the mythological story, Orion and the Scorpion are always on opposite parts of the sky because they are arch enemies. So when we go back at 9 o'clock and notice that Orion the Hunter is right here, just about to disappear in the west. If you were to turn around completely towards your back right now, which would be facing east, if you're looking over this way, the Scorpion is just about to rise up in the east at the same exact time. So when we get there, we'll take a look at those. So here it is. Oh, I turned us around. So here, let me go back. So here we're looking west. Turn yourself around west, southwest. That means you'd be facing east, southeast-ish. And right below the moon tonight, can you see that right there? That's the Scorpion coming up. Now, right behind my back is just the very ending of Orion the Hunter. They're always in the opposite direction of the sky. Here's a little bit later. This is like 2 o'clock in the morning. And notice just underneath the moon, there is the Scorpion. And by 2 o'clock in the morning, Orion, Betelgeuse will be completely gone just below the horizon. They are truly opposite in the sky. And oh, there's a really neat astronomer's phrase I want to show you before we look at the sky. If you're facing east, there's a bright star here called Arcturus. It's orange. It looks a lot like Mars. It's really easy to mix them up, actually. And there's an astronomer's phrase called arc to Arcturus. Now, I don't know if you can tell, but that's the handle of the Big Dipper. Here's the rest of the Dipper. The handle of the Big Dipper arcs to Arcturus. An arc is another name for a curve. And then you can spike onto Spica. It makes this big swooshing arc across the sky. Spica is the brightest star in the constellation Virgo. So if you ever see an orange star and you're not sure which one it is, look around and see if you see the handle of the Big Dipper pointing to it. And if it does, it's definitely Arcturus. So here's the constellation lines at the same time. Arcturus is part of Bootes, the shepherd. I always call it the ice cream cone. It looks like it's an ice cream cone lying on its side right now. There's Spica in Virgo, the beautiful maiden. And there's the Big Dipper's handle. So here's the drawings. And don't forget, you can arc to Arcturus and spike onto Spica. So make sure that you check for clear skies. Tonight is a definite maybe, probably not. I know it's kind of sunny now, but I just looked at the forecast. It looks like the clouds are moving in. Saturday night looks like a possibility. I think tomorrow night might be rainy as well. And don't forget that this whole entire recording will be on the YouTube NBTI channel. It's the U46 Science channel. All the planetarium sky shows, recordings are in that channel for you to look at any time you'd like. So let's go over now to our Stellarium program. Remember, this program that I'm using right now, Stellarium, is available for anyone. It's a free download off the internet. It's called Stellarium, S-T-E-L-L-A-R-I-U-M. It's fun to play with. It can be a little complicated. Trying to go full screen here. Oh, I was full screen. There we go. All right, so we're now in Germany. That's what this background is. This is the exact time it is right now, 1:20 in the afternoon. I'm going to fast forward. You know, we want to get to sunset, but I want to show you a cool feature while I do that. I can get rid of the atmosphere. Watch what happens when I get rid of the atmosphere. We can see all the way out. It looks kind of like nighttime. Now, it's not really nighttime, it's still daytime. That's the sun. But if I fast forward a little bit more, you can tell the sun, the stars, everything is moving down in towards the west. Let's back over this way. This is west right here. Go even a little bit faster. There we go. In the west, everything is moving down. Both the stars that are in the background that we normally can't see because it's daytime, and any planets that happen to be there. We've got Uranus and Mercury are both up right now. We can't see them because that pesky sun is so bright. Here we go down towards sunset. It doesn't seem real for me if I leave it like that. So I'm going to go back to what it really looks like. So here we are at 5 o'clock. 6 o'clock tonight, 7 o'clock tonight. Sunset is at 8 o'clock tonight. It's not even dark. Starts getting dark around 8:30. Here's 8:37. Let's go to 9 o'clock. 9 o'clock is a good observing time in the late spring and summer. See some satellites going by. As it's getting darker, I can see more and more. Those are all satellites going by. And here we are at about 9 o'clock tonight. This is our sky tonight. This is what we'll see if we go outside. Now again, I turn off the atmosphere. That light pollution, when it's gone, you can see sort of the haze of the Milky Way here. And Betelgeuse is behind the trees, pretty much gone by now. Gemini, the twins are up right now. Leo, the lion, is up right now. It's towards the south a little bit. I'll give you a moment to see if you can spot those on your own. And then I'll add in the lines and the names and the drawings. That is in the west tonight. Corvus is a pretty obvious one to find. In a normal suburban backyard, crater's a little bit dimmer. Leo the lion is right here. He's kind of face down. He's heading down towards the west. So that's the position that he's in. Cancer the crab is not visible from a suburban backyard sky, but Castor and Pollux are the heads of Gemini, the twins. And there's Venus right at the tip of the horn of Taurus the bull. And Venus is right between the bright star Capella and on the other side, Betelgeuse. Now at the same time, if we just stay at 9 o'clock, stand perfectly straight and then spin your body 90 degrees to the left. To do that, we're going to be facing south. Now you're facing south. Leo the lion is straight up, straight ahead of us, upside up, backwards question mark. The sickle is very noticeable. Corvus the crow is very noticeable. And what you'll really notice tonight will be the full moon. We do have a full moon tonight. What that means is at 8 o'clock, when the sun was setting, the moon was just rising. By 9 o'clock, it should be above the horizon. That's about the time you'll start seeing it above the horizon. It might even look a little brownish orange. It looks that color every single time it rises or sets. It's nothing special. It happens because you're looking through thousands of miles of atmosphere and the light waves are getting bent and we're seeing the colors at the red end of the spectrum. So know that it's perfectly normal at 9 o'clock for the moon to look kind of reddish orange. And if you see that, I challenge you, go out or at least look out the window in the east southeast 2 hours later, an hour later, and it will be a regular gray, beautiful full moon tonight. If we can see it, I'm going to cross my fingers. So that is the full moon looking in the south. And something kind of neat to do if we're looking in the south is to skip forward an entire day. So here we are at May 7th. I've got May 7th right there. That's tonight at 9 o'clock. Since we are at a full moon, I'm not going to do this in the south. Tomorrow at 9 o'clock, well, make a prediction. Where do you think the moon will be tomorrow at 9 o'clock? Don't forget it moves to the left a little bit every night. You ready? We're going to go one day into the future. Here we go. Ta-da! There's the moon. I mean, there's not the moon. There's no moon. Oh, it's still well below the horizon now. The moon was here. Now it moved here. It's below the edge of the earth. We won't be able to see it right at 9 o'clock at 9:10 tomorrow night. Stop time. I'll revisit that in just a moment when we're looking more towards the east. Here, let's go east. Just spun my body around. Now I'm facing due east, headed towards Chicago. If I turn these off, the brightest stars you'll see in the sky will be Arcturus. Hey, look, there's the handle. Arc to Arcturus and Spica to Spica. And there's that one called Corvus, the crow. And there's the moon. We can still see the moon facing east. It rises in the east southeast. Vega is a very bright star. That one will be just coming up in the northeast. And if I keep going, spinning my body to the left, oh no, sorry, I didn't show you pictures. There's the lines for everything that's up right now. And the names, a lot of people ask me about Draco the dragon. It's not a very bright constellation. I'm gonna, a little bit of this. Draco the dragon's tail snakes between the big and the Little Dipper. But none of these stars, notice how small they are. They're small because the smaller the star in this program, the dimmer it is. These are extremely dim stars. These two are somewhat noticeable. It has to be really dark to see these other two and then to find the rest of these along that path, but that is Draco the dragon. There's Virgo, Corvus the crow, and the moon is right on the scale of Libra tonight. So let's keep going to the left for our last cardinal direction of north. Now, if we look to our left, we're looking at the stars in the west. There's that corner of Betelgeuse again, and Capella and Venus. But as we face north, due north, there's the North Star and Little Dipper. And right above it in May and June is the Big Dipper. So this is exactly what it'll look like to the north tonight at 10 after 9. See, now what I want to do is, well, if we were to let time go on as we faced north, I want you to notice that everything spins around that North Star. We talked about that last week in Phenomenon 2, I think, 2 weeks ago. Everything in the sky spins around the North Star. And if we spin our body back to the left and look at the east, everything's rising up. And behind us, everything is going down. Ooh, it's 3 o'clock in the morning already. Ooh, I missed it. I think, oh no, we're right at it. This is good timing. At 3:41 in the morning, Jupiter, Saturn, and Mars are all visible. And if I get to 3:52, I think the International Space Station comes by 3:52 north, northeast, not very bright. Let's see if I'm right. We're almost there, 3:44 in the morning. There we go, 3:51:57. That's the International Space Station skimming along the horizon. Although I'm not a fan of 3 o'clock in the morning, I think I'll wait till next week and go out at 10 o'clock or 9 o'clock. So early in the morning, I'm going to stop here. Early in the morning in the east, I'm going to fast forward a day. Actually, let's go closer to sun. Oh, yeah, let's go a little later. Closer to sunrise. Sun is going to rise at 5:41. So let's go to 4:30 or so. Here we are, 4:30 in the morning. Tomorrow, that's May 8th. Let's fast forward. Here's May 9th. Here's May 10th. And if we go back to May 9th, you guys, that was the International Space Station again, right there in the Northeast at 4:42. So let's go forward now to the 10th. Hey, what's that thing in the upper right? Here's the 11th. Here's the 12th, 13th, 14th, 15th, 16th. The moon is much closer to us, and it's going around us, if you face south or east, to the left as it goes around the Earth. We can actually watch that if we compare it from one night to the next. So I'm going to go back in time again. So here we are in the 16th. Now we're back at 15, 14, 13, 12, 11, 10, 9, 8. So that's tomorrow morning. Here's the next day. Here's the next day. Here's the next day. Now, what date is this when it's going to be right next to Jupiter and Saturn? That is May 12th. On May 12th at 4:43 in the morning, they're going to look like this. So anytime before sunrise, you'll be able to see all three of them really, really close to each other. Here's the next day. Here's the next day on May 14th, a week from today, we'll be able to see the moon next to Mars. Now the moon is full today on the 7th. So a week from today, on the 14th, is it going to be bigger or smaller than full? Hopefully you said smaller. I'm going to click on this and I think that'll zoom me in. Yep, I'm going to zoom in. Make sure I hit the right button. Okay, here we go. Let's check out the size. And if you said half moon, ding, 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 you're correct. It's a last quarter moon. The left side is lit up, which totally makes sense because that's the direction of the sun. The sun is down here. It's about to rise in the east. Let's watch that happen. Sun comes up at 5:41, 5:20 a week from today. And there it is. Once that sun comes up, normally it looks like this, all bright and sunshiny when there's no clouds, but this is what it would look like if we could take out the atmosphere and the blue sky. This is what's actually happening. And you know, it's kind of neat to watch all of this from this view. We've got Jupiter, Saturn, the moon, Mars, Uranus, the sun, Mercury, and Venus, all in a line. Isn't that amazing? Jupiter, Saturn, moon, Mars, Uranus is there somewhere. You can't see that without a telescope, but it's there. The sun and Mercury, always close to the sun, and Venus, also always close to the sun. And that's because all of these objects go around the sun on almost the same plane. As we go around the sun, the Earth goes around the sun. All the other planets also go around pretty much along that equator line, you could think of it as. So when we see those planets and the moon in the sky, they're always on that same path, and we call that path the ecliptic. That is the path of the ecliptic. So I'm going to go back to right now. This is where we are right now. And fast forward a little bit to sunset. Go back to the west. If we look south, we can see stars rising in the east and then setting to the right on our west. And then this will be the sky that we see tonight. So I'm going to pause right there and go to questions. What kind of questions do we have?
All right. Our first question is, what time can I look for Venus in the sky tonight?
Venus in the sky tonight. Well, let's see. We've got Venus right there in the west. As soon as it gets dark out, I'm going to add atmosphere so this looks a little more realistic. It's only 8:15. It's not quite dark out. So hopefully if you're watching this, if you ask that question, you can sort of make an educated guess right now. Look at the timer down here. It's 8:16. I'm going to fast forward time a little bit. Here it's 8:20. I bet you can tell that it's starting to get dark out. And even before it's completely dark out, I can see Venus in the west as it has been for the past 5 months. Here's the bad news. Venus is very, very quickly moving in between the sun and the Earth. The Earth and Venus are both moving around the sun. Venus is going faster and it's about to catch up with the Earth, and it's going to pass us on June 3rd, which means it's going to be right in line with the sun. So every day as we're looking at it in the west, it's getting closer and closer to the horizon. By the end of May, we won't be able to see it as it gets dark out. So this is your last week to take advantage of looking for Venus in the west. And it's still pretty bright. Good question.
It is a good question. This next question is also a good one, and it's one of my favorite phenomena. What is the Aurora Borealis? But I think they meant Aurora.
Yeah, I think so too. There's no such thing as Corona Borealis, but there is Aurora Borealis. And Aurora Borealis means northern lights. Borealis is north, Aurora is light. So the northern lights are the lights that we see from planet Earth if we're way, way, way far north, or if we're way, way, way far south, like near the North Pole or the South Pole. And the magnetic field of the Earth comes in very close to the atmosphere at those points. Our magnetic field isn't a perfect circle around the Earth. It kind of pokes in at the North and South Pole. So when solar energy particles from the solar wind, invisible particles of energy coming from the sun, get close to the atmosphere of the Earth. They're not blocked by the magnetic field. They start to interact with the atmosphere, and the only place they can do that is the North Pole and the South Pole. That's where they get close enough to, where it can get close enough to reach the atmosphere, and it energizes the particles in the atmosphere and they glow. And if you're a human on Earth and you look north and you're close enough, you can see that glow in the northern sky. Or if you're in Australia or New Zealand or South Africa or South America, you would look towards the south and see the Aurora Australis, and that means southern lights. We have not had northern lights that were easily visible here from Chicago area in a long, long time. It's possible, it does happen, but we haven't had it in a long time. That is a good question.
Well, and this is a little bit of a follow-up question to that one. What is the best time to see the hands of Milky Way?
Yeah, that's a good question because I can't quite interpret the hands of the Milky Way.
Yeah, it says hands of the Milky Way. I'm not sure.
And it's H-A-N-D-S?
Yes.
Now the Milky Way doesn't have hands. I mean, it does have spiral arms because it's a spiral shaped galaxy, which I think I have an image of a galaxy behind me. Let me see. Yeah, so if I point right there, it doesn't matter how I move my screen, but it's the edge of a galaxy right there. And you can see one of the spiral arms goes all the way down here, actually connecting to some other material opposite it. But our galaxy is shaped kind of like a pinwheel. So it does have these spiral arms. And when you look up at the Milky Way, you're looking through all of those arms. So there's no hands that stick out from it. And if you want to, whoever wrote that, if they want to rewrite their question, maybe it was a misspelling, we'd be glad to try to answer that better if you read the question.
Well, you know, I think a good follow-up to that is, you know, where we live, is it easy to actually see the Milky Way, you know, or is there too much light pollution? Yeah,
the problem is there's too much light pollution. This is what our sky looks like as it gets dark out. I can go a little bit darker. A little bit later. So in the darkest of the dark skies, I don't see the Milky Way. But if I were to go away from city lights, and you guys, we live near Chicago, one of the biggest cities in the world. So don't think that your backyard is getting away from city lights. You have to go dozens, hundreds, thousands of miles from a big city to truly get away from all of the street lights that are up. But if we could, our sky would look darker like this, except for, do you see that cloudy line? Well, that cloudy line is the Milky Way. That is the Milky Way. And this time of year, it's very low on the horizon like that. At other times of the year, it crosses the sky higher. So if I could, nope, I want to go to date and time. So let's go back to, like, say, January. Get rid of that. So here it is, January. Now look in the same direction. Now, do you see that hazy line going almost straight up there? That is the line of the Milky Way. There it is going across the sky. It's a hazy line. Now there's areas that look darker. Those are dust lanes that are blocking our view. There are areas where it's thicker with a gray haze, other areas where it's darker. There's more and less stars, more and less nebula throughout portions of the Milky Way. And when you're looking at this Milky Way, you're looking out at a galaxy that's shaped like a spiral. And if I think of my hand as a spiral, if I hold my hand on the side, it looks long and skinny, almost like a line. But if I hold my hand like this, flat, it looks much wider. Well, when you see the Milky Way in the sky, you're looking through this part, the long and skinny part. You're looking all the way through the very thick galaxy with billions of stars. The far away ones are so far and there's so many of them, they make the background glow. That's why it looks like a line in the sky.
That's great. I didn't know that. We have a question from YouTube. from one of my personal favorite humans, and I bet one of yours as well.
Okay.
Mary Hill. First of all, she says, happy birthday to you.
Why, thank you.
And then her question is, if Orion is starting to disappear, a great winter constellation, which is the main seasonal constellation in our area?
Good question, because I look forward to seeing Orion all winter long. And then when it disappears in the summer, off the top of my head, if you ask me that question, I would say, well, in the summer, I usually look for Sagittarius and Scorpius. So I'm going to fast forward. We're facing south. I'm going to let the sun go down. Let's check that out. So Betelgeuse is still going down. Let's have him be gone. So if we were to look in the summer sky, we'd have to look not at 9 o'clock tonight, but later than that, maybe say midnight, 1 o'clock in the morning. This is what we'll see easily in the evening in June or July. And if I let that get to here, we're at 1 in the morning. Let's go to 2 in the morning. Ooh, and the Milky Way is getting in a better position here now too. Look at that. So here we are at 2 o'clock in the morning, say today. And if I put on the constellation lines, it might help you a little bit. We've got Virgo. I see the shape of the Scorpion. And I see the shape of Sagittarius that we often call the teapot. Sagittarius, the teapot, is right here. You take those lines back off. You can see the bottom of a teapot. And then here's the handle. And this triangle is the lid. And right here is the spout. It's just above the houses and trees in the south all summer long. And right next to it, very low on the horizon, is the tail. So here's the stinger, the business end of the Scorpion. And then right there is the heart of the Scorpion. The moon on May 8th will be in Scorpius. So let's put those lines back up. And the labels, and then there's the drawings. So it's like pincher claws are kind of up here in this area. There's the heart of the Scorpion. So I usually look for bright orange Antares, not to be confused with Arcturus. And if I ever want to know, geez, is that Arcturus or is that Antares, which is also orange, or is that Mars? I would look around for the Big Dipper. And if the Big Dipper's tail is pointing to Arcturus, I know it's Arcturus. But wait, I can't see the Big Dipper. Well, that's because we're facing south. If we're facing south, you won't see it. So we'll move and revisit that in just a second. But for evening constellations throughout the spring and summer, these two low in the south, Sagittarius and Scorpius, we also have right here, Cygnus the Swan. It's also called the Northern Cross. It really does look like a cross. If you take the drawing off, you can kind of see the big cross right here. Or the ancient Greeks called it Cygnus the Swan. And it's right next to Vega, which is the brightest star in our summer sky, connected to Lyra the harp. And then Altair, the eagle, has a bright star named Aquila. And these three are called the summer triangle. And these ones, if you look on this map, remember this is always the horizon. So this is pretty high in the sky, that summer triangle, the pizza-shaped triangle. That's another good one to look for in the spring and summer. And if we wanted to check Arcturus to see if it's, let's see if I can do it this way. So now I just turned my head. I'm looking straight up in the sky. This is the tippy top of the sky. My neck is actually getting sore from looking straight up. But I can actually see, if I zoom out a little bit, there's the handle of the Big Dipper, arcs to Arcturus. That is definitely Arcturus right there as I face south. So Sagittarius, Scorpius, the three that make the summer triangle, Deneb, Altair, and Vega are good ones to look for in the summertime. And a little later in the summer, towards the fall, so I'll have to fast forward here a little bit. That was too fast. No, that'll work. Pegasus, the great square of Pegasus starts to come up August, September, rising in the east in the evening sky. Hope that helps. doing your sky watching outside.
There was a question about why do we not want to look at the sun? So I know we've talked about this.
Okay.
I think it's
Yep.
always a good thing to discuss again.
Yeah, as a reminder, the sun gives off electromagnetic radiation. Part of that comes through as visible light. It's the sun that gives us light. But the sun gives off very high energy, electromagnetic energy, so much so, well, first of all, it burns my skin. If I go outside, if I went outside on a sunny day for 2 hours right now in May, my skin would be all red and burned the next day. But luckily, every day I'm growing new skin cells, and after the burn itches away and new layers of cells form, in a couple of days, my skin should look okay again. It heals, it grows new cells. Well, that same sunlight can do the same thing to the back of your eye, deep inside your eye. That black thing is a hole. And if sunlight goes into that pupil hole and hits the rods and the cones in the back of your eye, those are the cells that let you see, you can sunburn them. Here's the thing, you don't grow new ones, ever. So once you damage a rod or the cone in the back of your eye, it's just damaged forever. You wouldn't want to do that. You wouldn't want to stare at the sun. Luckily, our bodies recognize that the sun is very bright and our eyes react to that. The pupils contract, that often hurts. You say, oh man, boy, I can't even look at the sun. It hurts my eyes. Good thing, because if you kept staring at it, you would start doing damage to the back of your eye. It doesn't actually hurt when it's sunburning the back of your eye, just like when you're outside playing in the sprinkler or out at the beach or just out in the backyard playing, you don't feel the burn. You say, oh, it's beautiful. It's such a nice day out today. You don't feel the burn until a few hours later, like that evening when you're sitting on the couch and you realize your skin feels hot because it's burnt. The same thing would happen with your eyes. You don't feel the pain from electromagnetic radiation on your rods and cones, but it still does the burn nonetheless. So, and using binoculars to look at the sun makes that thousands of times worse. It happens thousands of times faster. So you never ever aim a telescope or binoculars at the sun.
Yes, that's good. So there was a question that came in. It was actually related to when we Corona Borealis instead of Aurora Borealis. And so then the student wondered if the coronavirus came from the Corona Borealis, right? So
great question. Corona means crown. There's a constellation up in the sky in the summer called Corona Borealis. There is such a thing as Corona Borealis. It's a constellation and it means crown of the north. And it's a perfect half circle in the sky. Corona Borealis is the name of it. So corona means crown and borealis means north. Now the corona also can refer to, actually I've never gone into the sun. Let's see. Let's see if it lets us see. No, the corona's disappeared from this. This is the sun without the corona. You know, that hazy layer of spiky gases that you can see on the edge of the sun, that's the corona of the sun. That's what you see when there's a total solar eclipse and the moon completely blocks out the disk. All you see on the outside edge is the corona. Well, the coronavirus, when scientists started spotting it, when they identified it and they saw it in the telescope, maybe somebody said, hey, it looks like it has this crown going around it, because it looked like it had like a fuzzy edge on it. And that's why it's called the coronavirus, is because it looks like it has a corona going around it when you actually look at the virus as a teeny tiny organism through a microscope. That's why it's called corona. The word corona has been around forever.
Well, you know, and it makes sense. So much of science is like that, right? I mean, I can think of a couple of different instances. Right now is a good time of year to get out and enjoy the spring wildflowers, because there's no tree leaves out. And so the UV light to the forest floor promotes our native wildflowers. But there's one that's called toothy wort.
Ooh.
And it's called toothy wort because it looks like teeth. And so people used to mash it up and put it on toothaches. Now you don't want to put toothy wort on there. It doesn't actually help it. The only reason they did it was because it looked like a teeth. And so they,
Oh.
that assimilation, they thought, you know, that it would do something for your teeth. So the Corona Borealis, the coronavirus, and as you know, we're people trying to make sense of all of these amazing things that are going on around us. And I think a lot of times we go with what we know, you know, or what we recognize.
Yeah, I find all that interesting. So you mean because it looked like it's a plant or something that looks like a tooth or kind of a wart, and then people thought that maybe
Remind people about of teeth. Yeah.
Good.
So they just, oh, it's good for toothache.
and then figured it was good for toothaches. But wait, it turns out it doesn't do anything to toothaches? You mean old-fashioned remedies like that don't always work?
Right. But some do,
But
right?
some do.
Where do we get
Interesting.
aspirin from?
Willow bark.
Yep. And that works.
And that definitely works.
Yeah. So that was a really good observation on the part of that student.
Yes, yes, very good. And I am rolling through here, trying to get to Corona Borealis. Do you see it at the top of the screen? You have to wait till midnight
Yes.
night to easily see it. There it is. Corona Borealis, it's a perfect half circle, and it is right next to the ice cream cone of Boötes. Arcturus is a star, and lo and behold, looky here, Big Dipper. There's the saucepan, there's the handle, and it arcs to Arcturus. Right near Arcturus is that Corona Borealis. And actually the Corona Borealis in olden times, and I'm going to take those words off because it's a little hard to see it. It's a crown. If you look carefully, it's a crown. The Pawnee Indians, and I learned this from the Natural History, the Field Museum in Chicago, they called this the Council of Chiefs because they pictured that as all the chiefs sitting around a fire, equal distance from each other, because all the chiefs had equal power in their kingdoms or tribes or whatever. And they called this constellation something different. They didn't even call it Corona Borealis. They called it the Council of Chiefs. Great question.
Yes. And that's the last question, unless somebody has one last second for us.
Question or comment or anything?
Yeah. Unless you want to give us any last thoughts.
Yeah, the moon will be good tonight. Even if it is cloudy, thin layer of clouds, you'll be able to tell where the moon is for sure. It'll be interesting, even if you don't go outside, just pull aside the curtains or the shades and look outside tonight with the lights off inside. And you'll notice that outside actually looks brighter than normal because that haze from the light from the moon will actually spread throughout the clouds, and it'll make the whole sky look like a cloudy gray instead of black. And the moon often makes it hard to see stars at night. So if it is perfectly clear, it would make it actually hard to see some of the dimmer stars. But of course, it's always neat to watch the moon from one night to the next and figure out where it went.
Well, thank you, Mrs. Hernandez. That was super interesting. And we all learned some things to watch for this week. Yeah.
And if anybody has any ideas to topics or subjects you want me to bring up in any of the next programs, put that in the question answer and we'll try to address it in a future show.
I think it's a great idea. What would you guys like to learn about?
Delphinus the dolphin's a good one. Look at that little tiny dolphin jumping. Delphinus the dolphin just coming up in the east at 1 o'clock in the morning, but it's up in our evening sky and in the fall. And it really does kind of look like a jumping dolphin in the sky.
That one is actually a constellation I can actually see.
Yep.
It means like sometimes I look at except for the Dipper. But.
Very near the summer triangle. Deneb, Vega, and Altair in the swan and the harp and the eagle. And then Delphinus dolphin right there. Kind of looks like a little jumping dolphin.
Nice.
All right. Good seeing everyone. Happy sky watching. See you next time.
Thank you.